Okay, so let us now proceed to applications of the three equilibrium equation. So this was not new to you because ito, na-practice nyo na sa statics or the engineering mechanics you had during your earlier subjects. So, you know how important the reaction is, no? Kapag nagkamali tayo dito, lahat na ng analysis mo mali na. So, we are not really allowed to have a mistake on obtaining the reactions. So, remember that we have three equilibrium equations to use because sa ngayon nga, determinate pa rin tayo dito sa theory 1. So, we'll just apply this summation forces along x is equal to 0. Summation forces along y is equal to 0. And summation moments is equal to 0. Normally, kung meron tayong beam, usually ang ginagamit natin is summation moments at both supports, performing these summation moments sa bawat support, and then we will have a check mechanism either using summation forces x or summation forces y. Okay? And normally, ito yung ginagamit, summation forces y is equal to 0 because most of the time, yung ating reaction is, yun nga, palaging vertical or most of the time vertical kasi nga yung mga loading natin is more on gravity loads. So, for this problem, we have here an inclined force applied to beam AB, say ABC, beam ABC, and this beam ABC is supported by a pin and a roller at B. So, dapat alam din natin gumamit or mag-establish ng free body diagram. So, the free body diagram, we'll just have to draw your structural element. Drawing natin yung structural element. Okay? As much as you can, kahit hindi magandang drawing mo, kahit man lang ikaw ang nakakaintindi ng drawing mo. Okay? So, as much as you can, your free body diagram should be comprehensive. That is why, in a solution, kailangan nating i-check yung solution because there are magical solutions. For example, you're a student and you come up with the right answer but cannot present it well in your solution. There's something fishy going on if that is the case. Of course, what I'm trying to point out is you must have to learn how to work on your own. Anyway, lahat naman dito pinag-aaralan natin. So, pagtiyagaan na natin. Ano? So, the key here is hindi naman patalinuhan dito sa engineering, kundi pasipagan. Okay, bakit pasipagan? Pasipagan ng solve. Kung lagi kang nagsasolve, ikaw ang magiging superior or ikaw ang mag-excel sa klase. Okay? So, moving on to this beam, ang gawin natin, lagay muna natin yung mga support reaction. Of course, this is a pin. We have already have the structure idealization. Ito yung tinatawag na structure idealization na kahit 3D yung drawing mo, you find a way how to simplify it through symbols and simple line diagram. So in this case, ito pin connection. This is a symbol for pin connection. So let us fix that one. Ito meron dyang pin and then roller here. Okay. So after the reaction, lalagay mo naman yung mga applied forces. And so far we have a single force here that is 60 kips. Okay. And then of course, we should know the distances here. So distance from point to point. We have 10 feet, 4 feet, 10 feet, 4 feet, 7 feet. So check mo kung lahat ba ay nandyan na. So nawawala yung angle dito. So ilagay mo yung angle. And of course, this couple here, 50 kips per feet. So this is the idealized structure from this picture. So the next step is to remove the support members from the structural member. So tanggalin mo lahat ng reaction at palitan mo ng equivalent force. Okay? So if this, sorry, perhaps we can place that lagay natin dito mas mababa. Bakit mas mababa? Kasi we will allot spaces for the forces. Okay? So ngayon, lagay mo na yung mga force. Yung mga force, pwede mo lang i-assume yan. Okay? So let us assume a force. We have here pin connection. There are two reaction. So I'm going to assume that to be upwards. So sometimes you do not need to assume because common sense will tell you na ito pataas kasi itong 60 naman yung component niyan is pababa and going towards the left direction. So meaning you must have to orient also yung mga components ng diagonal forces. Okay? And then another horizontal. So I'll just have that to be towards right. So of course, kailangan nating label yan so that we'll be having a abbreviation for every reaction. See, ito RAX and this is RAY. So yung 60 dyan, we'll be having a component here. So there will be a component for 60. Okay? A vertical and horizontal component. So ang gagawin mo lang, na kapag may diagonal forces, tandaan natin na dapat pag may diagonal, may alam tayong angle. Kahit saang angle, whether it come from the horizontal reference or vertical reference, does not matter, no? What is important, we will have an angle reference in every diagonal forces. So in this case, that is 60 degrees. Okay? 60 degrees. And then just follow the arrowhead of your components. So ito pwede nating sabihin, since ito is adjacent to 60, this is what function? 60 cosine of 60. Okay? And then this force is being projected here on the other side. As we can see, na itong force na to, parehas lang dito yan. Pero itong force na to, kailangan nating transfer to determine na ito opposite all of your reference angle. So therefore, we can say that this is 60 sine of 60 degrees. So this is computed to be 30. Okay, so this component is computed to be 30, and the other one, 60 sine of 60, is 51.96. Okay. perhaps we can just write it here. This is 30 and this is 51.96. So there will be a component for that one. Of course, kapag may diagonal, lagi natin kino-convert yan into horizontal and vertical component for the purpose of determining the perpendicular distance in a certain point. So in this case, kasi nga, mamaya magmo-moment tayo dyan, wala naman tayong diagonal or perpendicular distance. So ganito yan, kapag itong 60 ginamit mo, of course, kapag nag-moment ka sa isang point, say for example dito, ang kailangan mong distance, ito perpendicular distance. Okay? Mula dito hanggang dito. Okay? What is the perpendicular distance? Okay? This one. So, problema yan. Kaya, kino-convert po natin yung distansya or yung ating component in order to come up with a good presentation in order to come up with the distances or the perpendicular distances in order to apply the moment principle. Okay, so tapos na tayo dito. And then of course, meron din tayo ditong reaction. This is a roller, so there will be a single reaction here. Say this is RB. And of course, we should not neglect this force. This is 50. Okay, so this now is our free body diagram. And of course, we do not want to omit the distances here. Okay, this is 10. Sorry. This is 10. This is 4. And that is 7. So, normally, yun nga, may magkakaroon tayo ng check mechanism, and the check mechanism is just summation forces vertical or horizontal. But to ensure our reaction, of course, dapat mag-moment tayo at both support. So doing that, so if this is A and this is another support from B, we'll just have to take moments at A, then it equate it to 0. So next, we perform this one, summation moments A. Of course, wala nang distance yan. So, itong horizontal component will have no distance at A because it will just be intersecting this A. There will be no perpendicular distance. Itong 60 sine 60 or 51.96, the moment arm is 10. Okay. 51.96 times 10. And what is the rotation? That is clockwise rotation. That is positive. Okay. Next, RB would have a counterclockwise rotation. So we indicate that by a negative sign. So RB times what is the moment arm? From A, that is 10 plus 4, that is equivalent to 14. Okay? And then this couple, do not bother yourself in seeking for the distance kasi itong 50 na to, Newton meter na yan or kips feet na yan. So, ibig sabihin, wag mo nang hanapin yung distance. It is already a couple. Okay? And a couple is a moment. Okay? So, this has an orientation of a clockwise. So, that is positive 50. So, from left to right, we have no forces to accommodate here. Then, yan. Equate mo na sa 0 yan. So, makukuha na natin yung value ng RB. So, ito, RB is 40.69 kips. Okay, 40.69 kips. So, that is for RB. So, next, for the other reaction, of course, we will take moments on the other support. Summation moments at B is equal to 0. So, dito naman tayo mag-moment. Again, this horizontal component of 60 will have no moment arm, so that will be neglected. So, ito yung 51.96 will have a counterclockwise moment or rotation that is negative. 51.96 times the distance is 4 from B. And then RAY will be having what? A clockwise rotation, so that is positive. Okay. And from A to B, that is 14. Moment arm here is 14, and then we again plus that 50 is equal to 0. So RAY could be obtained here to be equal to 11.27 kips. Ngayon, pwede tayong magkamali dito. Kasi nga, yun. If we have some negligence in the solution or masyado tayong hindi maingat, so uncareful, pwede tayong magkamali. So our check mechanism is the other equation, that is summation forces X, y is equal to 0. Have we satisfied this one on this? So basically, itong dalawang to, RAY and RB is going upwards. So we are going to add that one, 40.69, going upwards, and 11.27 going upwards also. Both are positive. And then we deduct going downward first, that is 51.96. Is it equal to 0? So perhaps you can have a question mark there. So 40.69 plus 11.27, that is 51.96 minus 51.96. Then sigurado na tayo na tama na tong ating reaction. Okay, so ganun po. So kailangan nating mag-check mechanism. Ngayon, pag ginamit mo yan, huwag mong gamitin to para makuha tong RAY, because this is again for check mechanism only. So I would like to emphasize that, huwag kayong magmadali sa ating solution. Just go on with the summation moments in order to determine the reactions, and then ito check mechanism lang po yan. Okay? So now that our y-axis is ensured in terms of reaction, or the correctness of the reaction is ensured now, then isa na lang yung missing natin, RAX, di ba? So by summation forces along X, ito na tayo. Summation forces along X is equal to 0. Dalawa lang naman na force yan. We have RAX towards right minus the component, this is 30, okay? Leftwards 30, okay? So this one. So minus 30 is equal to 0. So basically, RAX is just equal to 30 kips, okay? Finally, kompleto na yung reaction natin, pero itong RAX tsaka RAY will have a mother result on A. Okay? magkakaroon yan ng resultant. Say this is RA. And we'll know that in getting RA is just equal to square root. To gagamitin lang natin yung Pythagorean, ano? RAX, this squared plus RAY, this is squared. So I'll just compute it directly, you know. So we have 30 squared plus 11.27 squared, then square root that, we have 32.05 keeps. Okay, so that completes our support reactions. So in the book, yung ating idealized structure, kasi itong kanyang presentation na yung 60 ay nasa ibabaw ng beam, and the pin connection is detailed on the center. So ganito yun. So if we strictly follow this type of setting, ito zoom ko lang to, yan, yung arrow na to ay nasa ibabaw at meron siyang distance na 1 foot on the center of this I-beam. So ngayon, kung ganyan, therefore magkakaroon tayo ng rotation caused by this 60. Okay? So yung ginawa natin kanina, we have neglected the distance of that one. We just assume that ito magkatapat lang yan, kaya nga yung horizontal nito is yun nga, naka-coincide dito. That is why walang distance or walang perpendicular distance. So following strictly this setup, there will be a slight difference on the answers. So if that is the case, we need to revise our idealized structure. So diretso na tayo sa free body diagram, ano? So perhaps anong gagawin natin, as much as we can, tatabain natin yan para to emphasize, just to emphasize the distance here. Okay? So just the same, meron tayo ditong RAY, and meron tayo ditong RAX. Siguro ilagay na natin yung component dito, no? So what is this 60 component vertical? A while ago, we have derived that to be 51.96. Okay. Sorry. 51 point, sige, 51.96. And then dito meron tayong horizontal component of the 60, and this is equivalent to 30. Okay? So ngayon, dati na yan, and then of course we have here RB. Okay. We have here RB. So for the distances, sige, gawin na natin yung distance. So let us just have this perpendicular distance here. Ilan lahat yan? 10. This is 10. This is 4. Okay. So ito naman, kung kanina tapat yan dito sa moment point mo, meron daw siyang distance. Okay, so this distance is 1 foot. Okay, yun. This one. 1 foot. So, just the same, we will just take moments at both supports. So, taking moments at the supports, now we have summation moments A. Kung A to B yun. Sorry. Perhaps we can denote this by another color. A, and this is B. So, summation moments A, we have 51.96 by 10. That is a clockwise rotation. And then, ito, magkakaroon na tayo ng rotation niyan. And what is the rotation? Counterclockwise. 30 will have a counterclockwise effect. So, minus 30 times 1. And then, this is a counterclockwise RB. So, minus also. We have 14. See, paliktarin natin. RB times moment arm of 14. And then, plus 50 is equal to 0. So, therefore, RB here could be now derived 51.96 times 10 minus 30 plus 50 divided by 14. We have 38.54. Keeps. So next, perhaps we can pagilid muna natin yan. For the other support, we will have summation moments at B. Okay. Summation moments at B is equal to 0. So at B, we have here, ito na tayo, itong 30 will have now a rotation from B. So ilan yan? We have 30. If this is 1, ibig sabihin this is 2, right? Because this is a center dimension here. So this is another 1 foot there. So the effect of 30 from this point, okay, we have a counterclockwise rotation that is negative 30 times 2. So negative 30 times 2. And then for this 51.96, that is a negative rotation. Negative 51.96 times 4. Okay. And then this one, plus 50. What else? We have RAX is located at the center. So RAX plus RAX times 1. Okay. And then plus RAY times 14. Okay. Did you get that one? So, let us have a recap. Negative 30 times 2. Where's that? This one. This is a counterclockwise rotation from B. And 30 from B is perpendicular distance is 1 plus 1, 2. 51.96, a counterclockwise moment times 4. Okay. 51.96, the moment arm is 4. Plus 50. Huwag mo nang hanapin yung moment arm kasi 50 na yan. Couple na yan. And then, plus RAX, clockwise naman to. So, we denote that by positive. 1 is the moment arm, and then plus RAY times 14 is equal to 0. So, anong mangyayari dito? Magkakaroon tayo ng 2 unknown variables. Why? Kasi nga, nagkaroon na ng distance yung RAX this time. Okay? So, before simplifying this equation, kahit na anong simplify mo dyan, dalawang unknown yan, isa-isang equation. So, we need to obtain another equation in order to solve one of these and then eventually come up with the other one. So, kung titignan natin yung RAX, talaga namang equal siya sa 30 by summation forces along X. Right? Ito, note ko dito, by summation forces X, we can say that RAX is just equal to the component of the 60 that is equivalent to 30. So, we'll just substitute it in here. Ito, dapat 30 yan. Okay? So, therefore, we'll now obtain here RAY. We have 13.42 kips. Okay. What else do we need? So, lahat na nandyan na, RB, RAX, and RAY. So, ang gagawin lang natin dito, RA is equal to square root of RAX squared plus RAY squared. So, diretso na natin, ano? Plus 38.54 squared. This is square root 40.81. 40.81 kips. So, these are the answers. We have RB here and RB 40.81 kips. So, that's it. If we are going to consider that an idealized structure, kinonsider pa naman yung thickness ng beam dito. That is why 30 here will not coincide to the point where you have taken your moment. Okay, so that's it for this problem. So it's so easy. Basta pagtiyagaan nyo lang, ano, you just check by the other equation and then employ taking moments in order to come up with equations or the solutions. Okay, so perhaps we can move on to this second example. So we are actually practicing here reaction. Okay, okay, for the next example, we have here a cantilever beam with a trapezoidal distributed load. We have the maximum pressure to be 15 and the minimum pressure is 5 kilonewton meter, both at the edge of the beam here. So we have to illustrate here an idealized structure and then come up with the drawing or the free body diagram. So for the idealized structure, we have here the cantilever beam. Okay, so this is the cantilever beam. And then we also have the loading. Okay, so we connect this trapezoidal loading. So the orientation of the loading is going downwards. Okay. So indicate the arrowhead to have a pressure of downwards force. Then we have here the label of the maximum pressure at the left portion and 5 at the right portion. Okay, so let us also indicate the distance here, 12 meters. Now, since we have here a trapezoidal type of loading, pwede nating i-divide to sa rectangle and a triangle or two triangles. Why do we need to divide that? In order to determine kung nasa saan yung centroid. Okay? Because remember, we are all familiar with kung meron tayong rectangle, nasan yung centroid niya? Nandito lang sa gitna. Okay? This is the center of gravity. And if we have a triangle, if this is, ito, kapag L yan, kapag L yan, ayan, L over 2 lang yan. Okay? And if we have a triangle here, so we all know that the centroid is nearer to the height. Okay? Because the volume is concentrated along this portion. Okay? So therefore, if this is L, the concentration of the center of gravity is 1/3 of L or L over 3. Yung naiwan dito, kapag L over 3 yan, 1/3. Yung pares ng 1/3 is 2/3 of L measured from the tip where the loading is 0. Okay? So the highest peak, doon natin i-measure yung 1/3. And then this will be the centroid. Ngayon, kapag trapezoid yan, hindi mo alam kung nasan yung centroid ng shape na trapezoid. That is why you must have to divide it in a way na ito i-represent ng rectangle or triangle. So, moving on, let us now have the free body diagram of this. So, as much as we can, lakihan natin. Okay. The free body diagram. So, we're gonna have here a trapezoidal loading. Okay. So, ngayon, pwede mong i-divide siya ng dalawang triangle. So, I'll just connect that one. So, magkakaroon na tayo ng dalawang triangle dyan. So, going back to the loading here, this is 15. And the other one is 5. We'll just have to get the centroid here. This is 1/2 base times height. 1/2, the base is 12. The height is 15. Okay? And for the other one, just measure 1/3 from the height. This one, 1/3 from the height. So that this will be the result of this other triangle. So this is 1/2 base. What is the base? The same base, 12. And the height is 5. Okay? So, of course, you wanted to indicate the distances here. Mga distances niya. Ano ba yung 1/3 ng 12? 12 divided by 3 is 4, right? That is 4 meters. 1/3 din ng 12 is 4 dito sa kabila. Sa kabilang triangle. Sa mas malaking triangle. Parang nagkabaliktad lang yan. Ano? 4 meters. So, 2/3 ng 12 is of course 8. Okay? So, the remaining distance from the 12. Okay? So, moving on. Magkakaroon tayo dito ng vertical force. Say, if this is point A, then this will be RAY. And obviously, wala po tayong force ng horizontal kasi wala namang horizontal force dito. And then, a couple on the fixed end. Say this is MA. Okay, so we will just employ the 3 equilibrium equation to solve for these 3 or actually these 2 reactions here. So basically, summation forces vertical, we'll just have to add these 2 downward forces and that will be the RAY. So if you wanted to write the equations accordingly, of course, you wanted to have to simplify first this result here. So 1/2 of 12 is 6. So 6 times 15 is 90. So we have here 90. And this is 12 divided by 2, 6 times 5. This is 30. So we have negative 90 minus downwards 30 plus going upwards RAY. This is equal to 0. And again, this is just the sum of the downward forces. So 90 plus 30, that is 120. Okay, kilonewtons. So this must be the answer for RAY. And as for the moment, of course, we'll just have to take moments at point A in order to come up with the moment. So summation moments at A is equal to 0. So we have 90 and 30 would have a clockwise direction. So 90 times the moment arm from A, that is 4. Okay. And for 30, again, this is a clockwise rotation. So we indicate that by positive, that is 30. And anong distance niya from A up to this point? Of course, 12 minus 4, that is 8, right? So that is 8. And then MA is assumed to be counterclockwise, so we indicate negative for that direction. Okay, so just the same, we will yield at a positive MA. So 90 times 4 plus 30 times 8. So we have here 600. So ngayon, itong mga reaction dito is just an assumed direction, ano? Pero, ika nga, kung may common sense tayo, we will have a good assumption for the direction. Pero wala namang problema kahit magkamali ka ng assumption for the direction, but just be consistent kapag nag-transfer yung mga forces. Kapag nag-transfer yung mga forces from one beam to another, equal lang yung magnitude but oppositely directed. So by and by, or for another example, we will go into that. So dito, halimbawa, nagkamali ka ng direction ng MA, ang mangyayari lang is, ito, magiging positive yan. And yung result mo, magiging negative na. Kaya, ibig sabihin ng negative, wrong direction or wrong assumption for the direction. But, there is no such thing as negative magnitude, but the implication is that your assumption for the direction is just assumed incorrectly. Okay, so wala namang problema doon. So kapag MA is negative 600, then i-correct mo lang yon magiging positive, and then just correct the direction. Okay, so this is 600 kilonewton meter. Okay, that's it for this problem. Okay, moving on to the next problem. Piliin na natin to. Okay, so we have here a framing system. Okay, so for this framing system, of course, we need to determine, ito kasi pin connected yan sa B, so magkakaroon tayo ng pin connection dito. So baka magkaroon tayo ng hesitation, we'll be having a doubt because we have here 2 pins. There are already four counts of reaction there. So 4 exceeds 3. That is why magkakaroon tayo ng duda, baka hindi kayanin ng determinacy yan. So we must have to check first our determinacy here. Of course, you wanted to have the idealized structure here. So ganyan lang naman yan. So dito meron tayong another pin connection here, and then this is the loading. Okay, this is internal pin, and we have here a perpendicular force on this diagonal member. So this is 8 kilonewton, this is 3 kilonewton per meter. So for the determinacy, of course, we indicate that there are 2 reactions there, another 2 here, and then C here is 1 for a pin connection, and then for the reaction we have, all in all, we have 4. Okay, so if we compare now R to C plus 3, so we have 4. Our C here is 1 plus 3. 4 is equal to 4. Just the same, magkakaroon tayo ng determinate structure. Bakit naging determinate? Because of this pin installed here. Okay? So ngayon, we'll now proceed to our analysis. So the next step is, again, illustrate the free body diagram of this. Okay. Sorry. So for the free body diagram, we have this beam here. Okay. So ngayon, meron tayong loading dito. This is 3. So usually, kapag meron tayong uniformly distributed dyan, we wanted to express it in terms of its resultant. Okay, so resultant is just the area of this rectangular section, rectangular loading. So parang i-assume mo lang na yung height niya is 3 at yung base niya is 2. So 3 times 2 is 6. Okay, nasa nakakoncentrate, nasa centroid, nasa gitna. Okay, so next, we wanted to place there the distances para wala na tayong problema mamaya. And then this is a pin connection. Of course, we have here 2 reactions going up. Say, I'll just have this to be no problem. Huwag kayong mag-alala kasi nag-assume tayo, mamaya sasabihin din ng ating solution or the result would tell us whether we have a wrong assumption or not. So this is RCX and this is RCY. So next, we wanted to place here the loading, which is 8 kilonewton. So ang next na gagawin mo, kung may diagonal, sabi nga natin, i-express mo na siya sa kanyang component. Okay? So, expressing it into components. So, pwede namang hindi. Anyway, meron naman tayong distance. Ito kasing 8, perpendicular siya dyan. Pwede natin gamitin yung distance na 2 meters if we take moments at point A by and by. Okay? So, let's see kung anong kalalabasan nito. So, we have here R AY, and let us assume leftwards for that. Say this is R A X. Ngayon, if we notice, there are 4 reactions already. However, ang option natin, kapag may pin dyan, we have the option to separate the 2. Okay? So, separating the 2 or detaching this pin actually will make this solvable by the 3 equilibrium equation. So, if I'm going to label this as A, B, and C, we will be having a free body diagram, a separate free body diagram for BC. So, dati na tayong merong RCY dyan, at RCX doon. Okay? So, ito, nakuha na natin yung resultant, which is 6 or 3 by 2. That is 6. Okay? And then, we indicate, dinetach natin. So, magkakaroon tayo ng 2. There will be 2 internal reactions here. Kasi nga, pin yan. So, if there are 2 internal reactions, then, we have here, I'll just assume it to be going upwards, ano? So, no problem, mag-assume ka lagi, ano? RBY, and then I'll just assume this to be going towards right. We have RBX. I'll just draw an arrowhead here for RCX. Ito going to the left. Okay. So, kitang-kita naman na yung 6. Ipaghahatian lang ng RBY tsaka RCY because we have here asymmetrical loading, right? So, by that, pwede na nating sabihin ng RBY, hating kapatid lang yan, 3. And RCY is also equal to 3. Okay. So, if we take moments dito, wala tayong makukuha kasi RBX and RCX is collinear. So, wala silang moment arm. So, we cannot get anything from this free body for a while. So, we can now transfer to the other free body. Okay? For the other free body, let's draw the free body of that inclined member. Okay? So, ngayon, ito yung sinasabi nating action and reaction. No problem sa mga assumption natin, but you must have to be consistent, ano? Okay lang yung mga assumption natin. Basta, kapag pataas yan, na inassume mo, anyway, nagtugma naman. Dapat, yung transfer niya dito sa inclined member is pababa at equal. Okay? Action and reaction forces, the same magnitude but oppositely directed. So, ngayon, kapag RBX is towards right dito, so dito dapat towards left. Ito yung RBX, ito yung hinahanap mo. Okay? And then, ito, meron na tayo dating 8 dyan. This 8 here is perpendicular to the member. And then again, ito, meron na tayo dito dating R, A, Y, and a leftwards R, AX. So, ano bang pares ng mga RAX tsaka RBX? Wala pa rin tayong kawala na kunin yung component nito kasi we need to align it parallel to the x-axis kasi yung x-axis may mga horizontal reactions tayo. So, wala tayong kawala in getting the components. So, let us get the component of 8. So, let us just draw a horizontal and vertical line. Okay. So, we have here a slope. May slope tayo ng 8, ano? 3, 4, 5. 3 horizontal. Okay, 3 horizontal. 4 vertical and 5. 3 horizontal. Okay, let us utilize that one. We have 3 horizontal. 4 vertical. Of course, 3, 4, 5 triangle yan. Okay, so we can just ratio that. If we're gonna label this as force 8 along X, and this is force 8 along Y, so ganito lang yan, kasimple. We'll just employ here ratio and proportion, ano? So, yung 8X dito, pares mo dun sa 3, at yung Y, pares mo din sa vertical. So, ganito yan. F8X is 2. What is the pair of horizontal? Horizontal slope, 3. And then F8Y, what is the pair of Y? Of course, the vertical slope, that is equal to 4. And this is actually equal to the mother force. Tanong pares ng mother. Siyempre, yung father or mother. Mother din na dimension. Okay, or the hypotenuse. So that both of these will be equated to the 8 over 5. Okay? So ngayon, we can write now F8X. Cross multiply mo lang yung 3 doon. Times 8 all over 5. So 8 times 3 all over 5. We have 4.8. So F8X is equal to 4.8 kilonewton. Okay, so similarly, F8Y, itong 4 will just cross multiply to 8. So 8 times 4 all over 5. So 8 times 4 divided by 5 is 6.4 kilonewtons. Okay, 6.4 kilonewton. So, ngayon alam na natin yan. We are now ready to move on to this. Okay. Of course, by summation forces horizontal, RBX and RAX still is not determined. Why? Kasi nga, dalawang horizontal lang unknown. So, hindi natin alam. Hindi naman equally divided po yan na yung F8X paggudwaan lang or paghatian lang ng RAX or RBX because it is not symmetrically loaded. So, we have no choice but to take moments at this point, okay, and come up with RBX. Okay, summation moments at A is equal to 0. We have yung 8, pwede lang gamitin yan. So remember, be consistent, ano? Kung ginamit mo yung mother, huwag mo nang gamitin yung component niya. Ngayon, pag ginamit mo yung mga component niya, do not use the mother force. Okay? So in this case, I want to show you that I'm going to use here the mother force. Anyway, sa A naman tayo nag-moment at yung 8 may perpendicular distance naman along this inclined. Ano yung perpendicular distance niya? So makikita natin dito yan. It is 2. Okay? This is perpendicular distance from A. That is 2 meters. So perhaps we can indicate here the 2. So going back to this summation moments at 8, 8 will have a clockwise rotation. So again, hindi ko na i-consider yun kasi consider ko yung mother force. So 8 times 2. Clockwise yan, and then about 3. We have a clockwise also for 3 plus 3. What is the distance of 3 from A? So, to 2 meters also. So, 3 times 2. And then, RBX is a negative rotation minus RBX times this distance up to this point. This is the perpendicular distance, right? And that is the height equal to 1.5 meters. Okay. So wala na, no? This must be equal to 0. So RBX shall be equal to 16 plus 6 divided by 1.5. We have 14.67 kilonewton. So ito nag-positive, ano? Stay positive. Okay. Nag-positive meaning yung positive ay hindi COVID yan, ha. This positive is meaning we have a right assumption. Correct yung assumption. So no need po na palitan na yung sign or the direction. Okay? So RBX is correctly assumed to be a compression. So by that, 14.67, we are now ready to have summation forces along X is equal to 0. Okay? On this member, we have negative leftwards RAX and we have negative leftwards RBX, and then we have here rightwards F8X that is computed to be 4.8. Here it is, 4.8 kilonewtons. So this is equal to 0. So pwede na nating ilagay dito 14.67. So negative 14.67 plus 4.8, we have negative 9.87. Transfer it to the other side, becomes positive. So we will be having a negative value for RAX. So RAX is equal to negative 9.87. Okay? So, meaning, pag 9.87 yan, negative, do not bother to change this one. Wag mo nang palitan yan. Ang indicate mo lang dito is the negative sign of it. So, automatic, yung negative sign niya yun, ibig sabihin, it is just towards right. Okay? So, RBX here is equal to 14.67. Okay? So, ngayon, pag inad mo yan, 14.67 na pa left, minus pa left din na R 9.87, it will yield to 4.8 nga na rightwards. Okay? So, we have a balance X here. So, these are the answers now. So, ngayon, pwede na rin natin makuha yung RAY. Just add 3 and the component of 8 along Y. What is that component along Y? So here it is, 6.4 kilonewton. 6.4 kilonewton. Component along Y. Or F8Y is 6.4 downwards and another downwards 3 here. 6.4 plus 3, that is 9.4 to be resisted by RAY. That is the only force going upwards. That is 9.4 kilonewton. So, kompleto na dito sa member na to. Balikan natin yung isa kanina. So, RBX is 14.67. So, therefore, ito, this is also 14.67. So, yung RCX is also 14.67. So, yan na. These are now the reactions. I'll just highlight those reactions. We have negative 9.87 RAX, RAY 9.4. We have here RCY and RCX 14.67. So considering now the whole structure, illustrating the whole structure here, buuin natin ulit yung structure. So this is the structure, okay? And then we indicate the reaction here. We have 9.4. We have negative 9.87. Siguro pwede na nating baguhin yan yung direction. Imbis na leftwards yun, dapat rightwards. Equivalent to 9.87. So, we have here going upwards 3 and going leftwards 14.67. And then the external forces, this is 6. Siguro ito, we just express it into components. What we have computed here for Y is 6.4. And for the horizontal, we have 8 na 4.8. Now, we investigate our reaction by summation forces X and Y is equal to 0. So when we have summation forces X is equal to 0, considering the whole structure we have, pa-right na 9.87, so that is positive. Pa-right na 4.8, it's also positive. And then pa-left na 14.67. So the question is it equal to 0? So 9.87 plus 4.8 is 14.67. So it's really equal to 0. So we are 101% sure of our reaction. Next, summation forces along y is equal to 0. So we have 9.4 going up minus going down, that is 6.4, and then going down 6, going up 3, and no more vertical force. So 9.4 minus 6.4 minus 6 plus 3, that is equal to 0. So again, we are 101% sure of our vertical reaction. Therefore, all of these reactions are correct. We can now proceed to our analysis. Okay? Okay. So that is for the examples. So for your exercise today, I will let you work with these two remaining problems here. For your practice. Okay, so have a glimpse on that problem. And then practice. By the way, this is a fixed end, ano? Sa A. That is a fixed end. And B is pin connected. So just absorb or regard these notes here. Okay? So gawin nyo yan. Kasi pag akong nag-solve nito, ako lang magkakaroon ng practice. You do not have any practice at all. So the basic here is you practice more problems or solve, and solve. So that's the secret in engineering. So I hope you work with this independently. Okay. So later on, I'll ask you, when we meet later on, I'll ask you about the solution of this one. Okay. So that's it. Thank you again. Have more practice and good day.